Hi Year 10 and welcome to the first of 5 videos that I'm going to do on the topic of logarithms. In this first video we're going to look at defining logarithms. So recall that multiplication is repeated addition. So instead of doing 2 plus 2 plus 2 plus 2 plus 2, we can write 5 times 2. Also recall that index notation is repeated multiplication. So instead of doing 2 times 2 times 2 times 2 times 2, we can do 2 to the power of 5. We also know about inverse operations. We know that division undoes multiplication. So if we start with a number like 4 and multiply by 3, we get 12. How do I undo that multiply by 3? I divide by 3. Take my 12, divide by 3, I end up back where I started. We also know about undoing index notations. If we take 2 cubed is equal to 8, what can I do to the 8 to get back to the 2? I can do the cube root. But here's the question. What can I do to the 8 to get the 3 to get the index? And currently we don't know how to do that. And the answer, of course, is logarithms. So logarithms strip the index off a number. That's their prime purpose. And it's what makes them so powerful. So if we take our example, log base 2 of 8, I'm going to turn that 8 into index form, which is 2 cubed. Okay, so I've told you that logarithms will strip the index off. So this is actually equal to 3. There's an easier way to think about it though. This is what it actually means. 2 to the power of what gives you 8, which is 3. Now logarithms have a base which matches the base of the number in index form. So let's have a look at our index notation. 2 cubed. The 2 is the base number and the 3 is the exponent or the index or the power. Now when we write it in log form, we write log base 2 of 8. And we said before that that's equal to 3. So let's have a look at the different components. The 2 is the base, the 8 is the argument, and the 3 is the power or the index. So here's some examples. Okay, remember how we read this? 3 to the power of what gives us 9? 3 squared. So the answer to this is 2. See how we've ended up with the index or the power? How about this one? 5 to the power of what gives us 25? It's 2 as well. Here's another one. 10 to the power of what gives us 1,000? Well, that's 10 cubed, isn't it? So the answer is 3. And finally, log base 4 of 256. 4 to the power of what gives us 256? Now you could use your calculator for this if you wanted to, but it's 4 to the power of 4. And so there's our answer, 4. There's one thing I want to point out just before we move on. For logarithms with a base of 10, we don't have to write the base. So if you ever see log of 100 just written like that, that means base 10. Okay, let's see if we can do this one. 10 to the power of what gives you 100? It's 2. Now, let's have a look at how we take index form and rewrite it in log form. So here we've got 5 cubed is equal to 125. Now the base stays the same. Okay, so it's going to be log base 5. This is going to be the answer, the 3. And this is the argument. So this is how we rewrite it. Log base 5 of 125 is equal to 3. Let's just check it. 5 to the power of what gives us 125? It's 3. Here's another one. 4 squared is equal to 16. The base stays the same, so it's going to be log base 4 of 16 is equal to 2. We're just turning it around. Let's go the other way. How do we turn log base 10 of 100 equals 2 into index form? This one's a little easier, isn't it? Because this is how we read it. 10 to the power of 2 equals 100. And there it is. Here's one more. Log base 3 of 27 is equal to 3. Let's start with our base. 3 cubed equals 27. Now recall with indices there are some special results. Here they are. The first one, the 0 index. Anything to the power of 0 is equal to 1. There's the negative index. Remember the negative means take the reciprocal. And then there's the fractional index. So a to the power of 1 on m will be the mth root of a. Now, not surprisingly, there are some special results with logarithms as well. Here's the first one. Log base a of a. So let's read this out. A to the power of what gives you a has to be 1, doesn't it? How about this one? Log base a of 1. Okay, that one's the 0 index. A to the power of 0 equals 1. So this is equal to 0. This one's easy. Okay, this is where we've got the base and the base of this index the same. So this means a to the power of what gives you a to the m. So that's just actually equal to m. Remember how logarithms strip off the index? Here's our reciprocal index. So a to the power of negative 1 is equal to 1 on a. And then finally, you guessed it, here's our fractional index. A to the power of what gives us the mth root of a? It's 1 on m. All right, let's see if we can put this all together. Log base 7 of 49. So it is 7 to the power of what is 49? 7 squared is 49, so the answer is 2. This one's log base 10, remember? So 10 to the power of what is 10,000? Now, you might remember the little trick for this. 10 to the power of what is equal to 10,000? Do you remember that it's how many zeros there are after the 1? So there's 4. So 10 to the power of 4 is equal to 10,000, so the answer is 4. Log base 2 of 16, 2 to the power of 4 is 16. Log base 5 of 1, that's the 0 index, remember? 5 to the power of 0 is equal to 1. The answer is 0. And here's our negative index. 4 to the power of negative 1 is a quarter. And then 5 to the power of what gives us the square root of 5? 5 to the power of a half gives us the square root of 5. Let's look at a couple of harder examples. So here's the first one, log base 2 of a quarter. So we've got a couple of things going on here. You can do that just by looking at it and writing down the answer, but I'm going to show you how to break it down. So the first thing I'm going to do is get rid of the fraction. So remember, a quarter is the same as 4 to the power of negative 1. Now, I know that logarithms strip the index off, but we can't do it at this point. Do you know why? Because these two things don't match. So the base of the logarithm and the base of the index have to match. So I need to change this 4 into 2 squared. So that's going to become 2 squared to the power of negative 1, which is 2 to the power of negative 2. Okay, now we can strip the index off, so the answer is negative 2. So you can do it that way, or you can just look at this and say, well, I can see that 2 has been squared to give me 4, and it's been inverted, so it has to be negative 2. So here's another one. Let's see if we can do this one without breaking it down. So again, I'm going to have to the power of negative 1, aren't I, because I've got a fraction. And then how do I get from 25 to 5? That's the square root. Do you remember how to do the square root in index form? It's a half. So the answer here is going to be negative a half. Now you might be curious, logarithms are not actually defined for negative bases or negative arguments. Now, a negative argument's easy, so when we've got a negative in here, this doesn't actually exist. So 2 to the power of nothing gives us negative 4. So that's obvious why we don't have negative arguments, but negative bases is a little bit trickier to understand. This one does exist. Negative 2 all squared is equal to 4, but this one doesn't. So negative 2 all cubed gives us negative 8, not positive 8. And so with mathematics, we don't want to define something that's erratic. Okay, we actually call this discontinuous, but we'll call it erratic for the moment. So existing for some things and not existing for other things. So we just don't define it for negative bases. Just while we're talking about this, log base 1 is also undefined. If you think about this, 1 to the power of what gives you m? That actually doesn't exist, does it? Okay, 1 to the power of anything is equal to 1. So we can't ever get m. So let's recap. We learnt that logarithms strip the index of a number. But here's the most important thing. This is the thing I want you to take away from this video. This is what log base a of b means. It means a to the power of what gives us b. Okay, that's enough for this lesson. In the next video, we're going to look at log laws.